Okay, welcome. Today, our conversations on scalable interaction paradigms for pervasive computing environments. So this is the conversation series of our priority program, which the DFG, the German National Science Foundation, is funding. And we are very happy to welcome in a second our international guest, Jakob Wobbrock. Antonio Krüger and me will be moderating the session of today on behalf of the project on gestures in pervasive computing environments. So let me welcome Jakob. Jakob Wobbrock is a professor of human-computer interaction. I think he's an expert in the field. He's known since many years in that. He's at the Information School and by courtesy, as he says, in the Paul G. Allen School of Computer Science at the University of Washington. I think he is one of the earliest who has actually founded DUB. I think maybe some of you have been at conferences where at least I remember seeing the wonderful DUB shirts, you know, when you appear as a team, the human-computer interaction and design at the University of Washington. He directs the Accessible Computing Experiences Lab and also co-directs the Center for Research and Education on Accessible Technology and Experiences. He aims to understand people's experiences of computers and information and improve those experiences by inventing and evaluating new interactive technologies, especially for people with disabilities. He has an exciting track record. Please, if you have not read of his work, go and find it. I think I still remember when one of my PhD students was so excited about his work in the early years of surface computing. And I think this is still, if I'm not mistaken, one of his most cited work on user-defined gestures for surface computing. So who could be a better international guest than Jakob on talking to us about gestures? And so we are very happy to have him for his work, My Work in Gesture. And there's a lot, I have to say, design, recognition, and open questions. Welcome, Jakob. We are looking for your short presentation and also for the conversation with you in a few minutes.
Thank you very much for having me. That was a very kind introduction. I'll go ahead and share my screen. Is that the right time to do that?
Yes, it's the right time to do that. Just go ahead. Hope everything
Okay. I'm just going to share my entire screen because I will switch between a couple windows here. Okay. Is that coming through?
Looks very good.
Okay, great. Let me make sure that we're sharing sound because we'll need that later. Okay. Yes, thank you for that introduction, and it's a pleasure to be with you. I wanted to present a little bit today about my work in gesture. I am from the University of Washington, which is in Seattle, up in the northwest corner of the West Coast of the US. If you haven't been able to visit, I hope soon we'll all be able to visit each other after the pandemic subsides. Little background sound. Okay, so I have conducted research into gestures and gestural interaction for about 15 years now. And I wasn't counting until I made this talk, and it made me feel old. But I've mostly been concerned with three main questions when I step back and think about it. And those questions, the first is, how can we design the best gestures for a given system? And what is best anyway? What is even a good gesture? Can gesture recognition be made easy in some way? Because it can be quite advanced and difficult for people to include in their work if they're not experts in various forms of computing. And also, can gestures be used to improve accessibility? This is part of my research profile, and gestures actually have a special place when it comes to their use in accessibility. And in looking at my work over these 15 years and making myself feel old again, I listed out a variety of the projects that I've done. I don't expect anyone to make sense of this slide, but for myself, it was a way of seeing that I've had a lot of involvement in gestures over the years, and trying to reflect on whether or not I've been successful in answering these questions. So I'll come back to this as we go through. But I'm going to return to my research questions here and color code them. And we'll use these 3 questions through this short talk. And also, I'm going to preview the main answers that I have found so far. For the first one, how can we design the best gestures? I'll talk about the end user elicitation method and certain tools that support that. For the second question, can gesture recognition be made easy? If so, how? I'll talk about the dollar family of recognizers. That's probably a strange name, but I'll explain that. And for the third question, can gestures be used to improve accessibility? I'll talk about our work in gestures for blind users, showing how that is possible. So let's go ahead and take this first question, designing gestures. And I've color coded the projects that I've been involved with here that are taking on this question about understanding and designing good gestures and what makes for a good gesture. If you have seen the movie Minority Report, if you're interested in HCI and gestures, you've probably seen the clip where Tom Cruise uses gestures to control his system in the future. We'll just watch this for a moment, but I want you to think about the following question. These gestures are fun to watch, that's true, but are they good? And how do you know? If you don't think they're good, how do you know that? What makes them good or not good? Let's take a look for a moment. Let's see here.
I show 8 Howard marks in the district, sorting by race and age.
Under license registration. See if I can capture that.
Running out of time. I was thinking maybe I'd play hooky, stay home today.
Right, meeting.
Working too much.
Can you grab that?
So clear.
I got 6 licenses. Where do you want them?
Over here, please.
Very slow.
So we just see some examples there of a number of gestures. We didn't see pinch to zoom. So not everything's an iPhone in this case. Back in 2005, I was working in my dissertation on a project called EdgeWrite, and it was a project that was trying to enable accessible text entry on stylus devices, which back then were the kinds of devices people were using. This is a Palm PDA like you see here. And the idea was that it's very difficult for people with motor impairments to enter text because the on-screen keyboards are very small and hard to hit the keys. And entering the gesture alphabet, the built-in one is called graffiti, was very difficult for people with tremor. EdgeWrite was premised on the idea that you could write in this square, and the corners and edges of the square would keep your stylus steady, and the alphabet gestures would be recognized by connecting strokes between the corners of the square. The problem is I wasn't sure that people could write letters that felt like real letters when writing in a square. That seemed like a strange idea. But rather than design the gestures myself, I had an idea to bring in participants and tell them the letter that I wanted and let them write whatever felt natural to them. And I did this with many participants, collected hundreds of gestures, clustered them based on their similarity, removed conflicts, computed agreement scores to see how much agreement there was on each letter, and ended up with a participant-designed, conflict-free gesture set that had multiple alternatives for each letter. And then I compared it to the built-in graffiti alphabet, which was considered very guessable and natural. And it turned out that even though we're writing in a square in this strange way, EdgeWrite was more guessable to people who had never seen graffiti or EdgeWrite. And I thought, this is an interesting way to design gestures. Give people what you want them to produce and have them make the gesture that feels most natural. So we brought that forward 4 years later to Microsoft Surface, which has been since reused on a new product, but back then was this tabletop that you see here. And this, in fact, is the paper that Suzanne mentioned at the start of the intro to the talk. It is my most cited paper. It's really sort of taken off, and a lot of people have referenced it, which is nice. But this is the user-defined gestures paper, but it's the same methodology actually that we use to design the EdgeWrite alphabet. And the idea, again, is you show people what we call the referent or the effect of the gesture, and then you ask them to perform the gesture or the symbol is the more general term to make that. So here's a video that will show how this happens.
Shrink. Pretend you are making an object smaller. Here's an example. Gesture now with one hand.
I'm using my thumb and my forefinger and drawing them together over the object that I want to become smaller.
Interestingly enough, this person did not own a smartphone. This was 2008, and most people didn't have a touchscreen phone yet. So that pinch to shrink in that case was something that they felt was kind of intuitive. The problem, though, is that what people do find intuitive often is what they're already familiar with, which calls into some question the notion of a natural gesture. I'm not sure I actually think there are such a thing as natural gestures, but there are things that seem intuitive based on what people already are familiar with. So this person is going to imagine that this is a drawing canvas that he can select the object to get drag handles like you would an object, say in PowerPoint, and then you could drag the handle to enlarge, in this case, the object. Let's take a look.
Well, the premise to this action is based upon previous experience in the programs. When you select an item, it usually highlights around it with a box, and then at that point, take and drag the box at an angle to enlarge it.
So we can see he's relying on things with which he's already familiar. That's not a bad thing. It's just a very common thing that people go back to what they already know. We also created a number of tools. I won't go into the details here, but a lot of tools along the way helped us do this kind of work. So Gecko helped us cluster similar gestures. Great was a tool that computes accuracy measures over gestures. Ghost visualized gestures as heat maps. Agate could be used to compute agreement scores for both within and between subjects studies. We built these tools, and they're all available online. You can download them and use them. They're fairly versatile and flexible. Eventually, because running these elicitation studies is kind of laborious in a lab, we built a crowdsourcing platform. This gets to your question about scaling, called CrowdLicit. It also had a component called CrowdCensus. CrowdLicit allows researchers to run elicitation studies online with the crowd, and CrowdCensus uses crowd workers to vote on gestures that are similar, or not just gestures, actually, could be voice commands or icon sketches or any kind of symbol, and then uses some unsupervised machine learning to do clustering to figure out what is the greatest consensus over the gestures that are proposed. And finally, sometimes it takes a while for things to emerge, including theoretical developments in different methods. So over time, we saw some debate about how best to compute some of these measures, like agreement. In 2018, Sandillis published an article arguing that all of the agreement calculations are flawed because they don't take into account chance agreement. And Vatavu and myself studied that work very closely. It's quite deep, and found that, in fact, we think he omitted the notion of chance disagreement, which we believe we can show mathematically always is in direct balance and opposition to chance agreement. So we have an article coming out in the January edition of Tokai that responds to his article and tries to offer some more clarification. So this is fun when something reaches a point of maturity where some of the finer details can be worked out. So what have I learned in this elicitation work? A lot of things, but I'll leave with three on this. Scaling gesture interaction means figuring out the gestures that users find most intuitive. But what users find most intuitive is often what they already know. And so sometimes it's hard to get them to take a leap into the future. Methodological refinement of any kind takes time, even a decade. And that's just part of how those kinds of projects go. Let's go on to the second question. Can gesture recognition be made easy? I want to share a few things here. And you can see on the timeline, there's a number of projects that all start with a $sign, which is sort of strange, I realize, and I'll explain that. But the idea here takes me back to about 2003. I was an intern at Microsoft trying to implement gesture recognition for that Surface table. And I was trying to use Rubine's recognizer, which really was the main thing published for this kind of stroke recognition, from a SIGGRAPH paper in 1991. This is quite a popular paper. And it was using training examples of gestures. He defined 14 different features, which are all sort of geometric or trigonometric in nature, and then did a number of statistical computations on those features to match the gestures. The thing is, it was kind of complicated. It involved things like Mahalanobis distances and discriminants and matrix inversions. It was about 2,000 lines of code. And also it didn't recognize very well unless it had many training examples. In fact, it would sometimes not even recognize its own training examples when given as a gesture candidate. So I thought there has to be an easier way to do this. I'm not an expert in AI or machine learning, but I'm an HCI person who wants to put some gestures in a prototype. Why is it this hard? So I created the dollar recognizer, which is named that because it's about 100 lines of code, very cheap, simple, and easy. And it follows 4 steps. First, we resample the gesture path. So you can see the raw gesture turns into a gesture where the points are equally spaced over space and time. Then we rotate the gesture from its centroid. The point from its centroid to its first point gets rotated to a reference angle, like 0 degrees. Scale and translate the gesture to a reference location and size, and then simply compare it to templates that have been treated the same way. It's really quite simple, but surprisingly had never really been written up. And it worked quite well. In fact, it really beat the crap out of the Rubine recognizer, if I may say. But the thing that might have been most interesting about this was that I published the entire code in pseudocode as the appendix of the paper. I'd never done that before. I'd never seen anyone do that before, but I couldn't figure out how else to get this into people's hands. And this was back when we were limited to 10 pages, including references. You had to keep it within 10 pages. So it was not a small choice to do this, but that's the entire recognizer right there. And in fact, if you look closely, it's pseudocode, but it's low level. So each line translates pretty much to one line of real code, and that's it. And it recognized very well. We went on to use two extensions like $, which went from unistrokes to multistrokes, $, which was a much more efficient point cloud style recognizer, and then $, the most recent one, which is just much faster. It's about 150 times faster and suitable for very low powered devices. it gets that speed up by using lookup tables. Each of these has an online demo that you can find if you just search for it, but they look something like this. I'll do that thing you're not supposed to do and do a live demo. So this is the $1 page. You can see some gestures here, and if I just make a stroke with my mouse, you can see it says it's a triangle, took 12 milliseconds, and an arrow. And notice this arrow kind of goes up to the left. If I want to go to the right and have it recognized, that's going to match differently because the stroke order direction matters. But I can then simply say, I want this also to be an arrow, and I just add it. Now it's a new template for arrow, and now it should recognize arrow, right? So it's very easy to customize and extend, and each of those recognizers has different advantages. But you can play with those online. There's JavaScript reference implementations there, as well as in other code like C# or other languages. Also contributed by a lot of other people, versions in Python and all sorts of stuff that I put on the webpage as well. Well, it showed me that there was a need for this, because within about a year, this recognizer was finding its way into all sorts of things. This was a $10,000 award-winning game that was produced by a company called POW Studios. And I'll just show you a brief clip where you see gestures being drawn to play the game. Arcs and hearts and writing a whole word, POW, that's a big boss battle type action. Here's an educational app that used $N to help kids learn how to make gestures.
The goal is to write a number using a touch motion, providing an intuitive and innovative way for learning on the iPhone, iPod, or iPad platforms.
Here's $P being used actually for hand pose recognition, because it's a point cloud recognizer, so it can handle strokes and poses, and it's being used to fly a drone. And here's $Q being used in an augmented reality scenario. So you can see there's various shapes and things being drawn there. Sorry about that. Sometimes it won't advance the right way. Then what happened is other people started adding these dollar family gesture recognizers as well, and took on the naming. So 3 cents and €1 and QuickBucks and $3 and a variety of names that are similar. All of these adopt a similar philosophy, which is keep them very simple and easy to implement, and often include the entire recognizer in the paper itself. So what I've learned here is that scaling gesture interaction means making gesture recognition easy for designers to adopt. If it's too hard to include, it's hard to get out there. I also learned that if you experience a need in your own work, chances are others have that need too. So sometimes figuring out something that was your own challenge will also help others, and maybe consider making it something they can use. And the last thing is making complex things simple is often a worthy research challenge, and others will thank you for it if you succeed. Too often in academics, we make simple things sound complex, but making complex things sound simple, I think, is more of the art that we should be after. Okay, one last quick section. Gestures for accessibility. What does that look like? And we particularly focused on projects involving blind users. You can see some of them highlighted here on this timeline. And the idea is that unlike pointing at targets like we do with a mouse or with our finger tapping a button, those are very visual activities, right? They're very sighted activities for the most part because we're aiming at things. But with gestures, it's a motor movement that we as the users control. And that could be a very powerfully accessible kind of thing. So we wanted to look into that. And we started this largely with a project called Slide Rule, which was, to the best of our knowledge, still the world's first finger-driven screen reader. Screen reading at this point was mostly a keyboard-based thing that you did for documents or web pages, and you use the keys to control the speed, but it kind of read from the top left to the bottom right of a document. With a finger-driven screen reader on a touch screen, the reading would happen under the finger. And that presented itself with some various challenges. Like if you move the finger quickly over the screen, what does it read? Versus if you move slowly, does it read, for example, in more detail? That's exactly the kind of thing we did in the Slide Rule prototype. We built this on an iPod Touch back in 2007. The paper was published in 2008. And back then you couldn't write code for the iOS devices. There was no SDK, there was no App Store yet. But we found a hack that we could inject code. We couldn't draw graphics to the screen though, only solid colors. But since this is for blind users, drawing to the screen wasn't necessary. And you can see here the idea that as the finger moves, the contents of the screen are read. And when a user wants to actuate a target, they don't lift and tap. They actually do a second finger tap anywhere on the screen, and the target that's under the reading finger, the first finger, is the one that is actuated. And you'll see it in action. It'll make more sense when you see it. But this allows for risk-free exploration of the screen because you can't accidentally tap something. And it also makes the target that you have to tap the entire screen. So you really can't miss. And this was a key insight. In fact, Apple let us know within a year of seeing our video and paper that Slide Rule had been very influential in their design of VoiceOver, which is their accessibility software that ships on every iOS device these days. In fact, what we called a second finger tap, they called a split tap, which is, I think, a better name. They have a better marketing department than we did. Let's take a quick look.
Home. Phone book. Mail. Music. Phone book. Mail. Music. Phone book. Mail. Music. Phone book. Phone book. 10 contacts.
So there you can see the split tap.
The Audrey Hepburn. B. Bill Cosby. F. Frank Sinatra. 4 of 10. J. James Stewart. J. Jason Bateman. K. Kevin Costner. 7 of 10. Calling Kevin Costner. Mail. Mail. 10 messages. 1. Patrick Stewart. Final question. 1 of 10. 2. Nicole Kidman. Quick question. 3. Charlie Chaplin. Please answer this. 4. Will Smith. Question for you. 4 of 10. What month is it today? Music.
So one nice thing that came of this, after 10 years, we received the Lasting Impact Award for this work at Assets a few years ago. That's Sean Kane, who's at the University of Colorado Boulder, and my former student, and then Jeff Bigham, who's at Carnegie Mellon University. Both do a lot of great accessibility work. And the same idea we applied to real world physical documents with gestures. So point a camera at a piece of paper and have it OCR'd on the text, and then track the hand with computer vision and essentially make Slide Rule for documents. So I'll just show you that real briefly here.
Document detected. Starting OCR. Recognized Lake City. Recognized University District. Recognized Ballard. Recognized Queen Anne. Recognized Capitol Hill. Recognized Downtown. Recognized Rainier Valley. Recognized West Seattle. Rainier Valley. West Seattle. Downtown. Capitol Hill. Downtown.
One last project I'll show quickly is Perk Input, which uses a Perkins Brailler to allow a blind person who knows Braille typing to type quite rapidly with one phone, two phones, or a tablet. And you'll see how quickly they can enter text here.
A user can also enter text on a phone twice as fast using two phones.
Connecting. I space C-A-N space U-S-E space T-W-O space P-H-O-N-E-S space T-O space G-O space F-A-S-T-E-R.
Perk Input can also be used to enter text on a tablet.
O-R space U-S-E space T-H-E space T-A-B-L-E-T space W-H-I-C-H space I-S space F-A-S-T-E-S-T.
A longitudinal study with 8 blind.
We can see there, but in that case, those are chording gestures, which are harder to learn. But that user was a blind woman who already knew Braille and Perkins Brailler input. So translating it to the phone was relatively straightforward. So what have I learned from this line of work? Scaling gesture interaction means making gestures available to everyone. And indeed, they can be performed non-visually and are usable by blind people. In another study I didn't present, we showed that, in fact, gestures can be quite preferable to people who are blind. I also learned how novel interaction techniques really require that we get the details right. You know, little details make a big difference. And so there's just a lot of attention to those things in this kind of work. So some final questions concerning this notion of scalable gestures. And I group them into scaling to the future, scaling to the body, and scaling to all people. For the future, how can end users propose good gestures for deeply unfamiliar technologies? We have this challenge where in these elicitation studies, sometimes they really do stick to things they're familiar with. But if we're really thinking out in the future, sometimes that's hard. Certainly users are not designers. They can provide data for design, but they themselves aren't designers. So there's ways to improve that, I think. Scaling to the body, could there be a dollar family type of recognizer for whole body gestures? If you think about the Microsoft Kinect or other skeleton tracking types of technologies, they're much more complex than stroke gestures or hand poses. And so that's still a real challenge for a designer to include that kind of gesture recognition in a prototype. And scaling to all people, how can gestures be useful for people with disabilities other than blindness? EdgeWrite dealt with motor impairments a bit, but for the most part, we are seeing gestures being useful for people who are blind, but I think that there's more exploration that we could do there as well. So I just want to thank a few people who've been part of these projects: Meredith Ringgold Morris, Radu Daniel Vatvu, Lisa Anthony, Sean Kane, Shiri Azenkot, and other people as well. And acknowledge some of the support: National Science Foundation, Microsoft Research, and NISH. And I'll stop there. Thank you very much for your time and attention. I appreciate it.
Thank you very much, Jacob. That was exciting. That was an exciting journey through your research. If you want, you can, yeah, exactly, stop presenting, and we are maybe moving into a exactly a more familiar mode of question answering. You started starting already posing questions that exactly relate to our research. Thank you for that. And maybe Antonio and me start with a few questions. And maybe the first one is you know, we are moving now into mid-air gesture. So we are really now moving into the full space, you know. So I think you indicated, you're saying that's okay. How is that going with the full body at some point? Do you think that we can generalize it in some sense? Can we really develop, this is our goal, more or less a gesture vocabulary? Because our biggest concern is that we have 100 of thousands of different environments, and each comes with their own little wonderful but different vocabulary. So I cannot switch on the light in your house. Maybe you don't want me to do that, but let's see. And the other question is, you know, with every device I walk up to, and we can anticipate that there's going to be 100 of gestures, I will not be able to work with the system. So what do you think about mid-air gestures and the question of scalability?
That's a great question. And I think it's actually a really hard question. Before I answer, though, I just want to say really quickly, I recognize a few people's names in the audience. So hi, Jan. Nice to see you. And a few others. But yeah, so, you know, I started some of this work under what I'm a little sorry to say, I think was a little naive impression, which maybe there is a way of arriving at gestures that are so intuitive to people that they would be easy to reuse for various systems and across applications. And I don't want to sound too negative, but I'm actually pretty skeptical now that that is a likelihood. And I instead adopt a little bit of a different picture of this mentally, which is that gestures are more like the evolution of a language, of a spoken language, for example. And so and I'm not a linguist, so I don't, you know this evolution deeply, but we know that language evolves. We know that words that used to have one meaning kind of change over time and move into common use or fall out of use. So gesturing, I think, can also be thought of, and many psychologists have looked at gesture as language and certainly as part of language. And I think that there is the development of gestures as language. And so what that means is, as gestures find their way into more common use, people learn the words, so to speak, right? They learn the gestures and they get familiar with these things over time. It's evolutionary. And then what feels intuitive are things that they've learned. And over time, there's kind of the adoption of a language, but it's, I don't think, something that will be easy to just design and it's just correct and then it's sort of talked down and finished and reusable. So the more people that have phones in their hands, the more they get used to swiping and pinch to zoom, and that will seem then something maybe they'll try. But it's because they've begun to learn this language of gesture through their experiences over time.
Yeah, I think we're coming back to that question, but for me, it's still the question, is that quick enough? Because the pervasion of really gesture-based interaction, that is no more or less exploding, and has reached like every place of our daily and work life. But then sort of waiting until it kind of adopts, it could be, first of all, too slow. And the other thing, you are, as I understand, working strongly in accessibility, could leave a lot of people out, not necessarily only with disabilities, but people who are maybe on the other side, as we call it, the digital divide. It might not be able to sort of stay at speed with all of these developments. So that would be before I hand over, a question of, do you think really waiting for it to be adopted is the right way to go?
Well, I actually think that your question has within it something of the answer. Because it's exploding and spreading so quickly, that in fact is bringing this vocabulary to so many people much faster than natural language, for example, would presumably evolve. But the issue is that if we depart too much in a novel system from what people have already been exposed to, then they may not find it very intuitive or usable. So the spreading of gestures is quite fast, but the expressive range of gestures might in fact be kind of basic. I mean, if you think about again, with the iPhone, for example, or an Android phone, what gestures really do we use? We use tap, we use swipe, and occasionally we pinch. That's kind of it. So we have a 3-word language right now.
Yeah.
Right. But those are familiar to people and they can't break out of that familiarity once they've learned it. So widespread, yes, learning quickly, but maybe the vocabulary is just kind of small.
Okay, so I think I see Jan raising his hand, and then maybe Antonio also.
I can ask always question, but let's start with Jan actually. Yeah.
Hey, yeah, thank you, Antonio, and thanks, Jacob. This was a great talk. The first thing I'm taking away from this is, since you showed the Minority Report, it finally confirms to me that what I always suspected in most other science fiction movies, that most of the computing in the future will happen on transparent sheets of acrylic, which is great to know and see confirmed in that clip. But on a more serious note, there's 2 things that I wanted to ask you about gestures. The first one is visibility. I find that a lot of interfaces with using gestures, of course, suffer visibility in the traditional sense of usability, because there isn't really any way to know that you're supposed to swipe in, from 2/10 off the top of the screen until just about the middle of the screen to do something. And I'd love to hear your take on this, because this must have come up, and maybe, especially maybe in the accessibility world, there's actually where I'm guessing most people have knowledge in the head, as we say, rather than in the world, because they need to know these things anyway. Right. So I just would like to hear your take on visibility. And part 2 would be what you just said about language. Got me thinking, if you compare gesture vocabulary to a language, and not just a set of gestures, then I'm wondering, what is your take on structure? Because language basically really starts to, explode and really work when you have structure. You've got hierarchy, you've got nouns and verbs, and you got sentence structures and all these, this whole syntax that then carries semantics with it and so on. So does the equivalence still work and do you see that maybe we build a vocabulary of basic gestures that would be like the letters or whatever, and are they combined into words and sentences at some point when we interact?
Yeah, let me maybe take the second one first, and then I'll come back to the first one. I took a note so I won't forget. Great questions, also hard questions, I think. Actually, the work on, so the structure question, I think, is sort of, again, with the language analogy, one of grammar and syntax, really. So some of the work that that comes to mind that I think if people are interested in this, they should look up, is work by Ken Hinckley at Microsoft Research, who there's a particular paper that's coming to my mind, but I know there are other ones he's done on this too, which is a paper called Scalable. Here, I'll type it in the Scalable. I think that's, wait, there we go. I think that's the spelling. And it's in the chat window. And it's looking at gestures and whether or not we use gestures to, for example, in a pen gesture to lasso a group of objects first, to select them, and then carry out the verb that should happen to those objects, right? So we kind of do the nouns first and then the verb. Other systems, and we can all probably think of some, you pick the verb first and then make an action for the noun. So maybe, well, I don't know if I can think of one right off the top of my head, but So we see
in X windows, the X window, frightening, kill the next window I click on kind of mode that you could get into, where your cursor turned into a little skull, right?
Yeah.
That's clearly the action first, and then you pick your object.
Yes. Right. Yeah, exactly. Thank you. That's a good example. Yeah, so we see this kind of grammar kind of stuff happening, syntax in those examples. And I think in Ken's work, especially, there is gesture very much at the heart of that. As far as conclusive discoveries, I have to say I'm not aware if there has been shown to be kind of one best way of combining gestures in certain kinds of syntactical structures. I also fear that might be what's best, might be quite application dependent and situation dependent. But there might be some more recent work I'm not aware of that tries to do that. There's probably a really good paper that someone in this group should write called something like the syntax of gestures, or the grammar of gestures. But it's, to Suzanne's question earlier, it's hard to figure out how to get to that in a application independent sort of way. And I don't know if we just have enough examples that through induction we decide typically it's the best way this way or that way, but I don't know that there's a deductive way to get to that answer. Gesture discoverability, I take as your first question. There was a nice paper I remember from WIST 2008, again showing my age here a little bit, but it was by last name of the first author was Bau, B-A-U, and it was I'll put it in the chat. I believe it was with 2008. I might be off a year or two, but it was called Octopocus. And it tried to preview the gesture that you would make as you started making it. And it would narrow the space of possibilities as you began to stroke. All the paths you could take that were valid would sort of show transparent. And as you kept going, that possibility space would narrow down. And as you finish the gesture, of course, now you're down to one possibility. And it was just a really nice, elegant way of trying to make gestures discoverable. And it's certainly not the only paper to try to do this, but that was one that people might look up if they're curious. I think that discoverability of gestures will be always an issue with the use of gestures. And how we visualize gestures is actually itself kind of a challenge, because showing static charts or static figures, for dynamic action, it's usually not a great match. And so that's sort of fundamental as well, I think. It's a great question.
And I guess related to this, Jacob, is also, as you mentioned, to provide also feedback during the gesture. I think this is something, guidance and feedback. And this nicely kind of ties to also the accessibility actually research that you've done, where basically guidance and feedback in different modalities, of course, is also crucial to get this running. So it's not only discoverability, but also the amount of guidance and feedback. And again, my feeling here is this is in a certain way also not easy to do in the right way. What would be the best, not only the question what's the best gesture, but also what's the best actually environment to perform and to guide the gesture. What would be your take on that?
Mm-hmm. Yeah, I put some words in the chat as well. I think I talked in my talk about guessability, which is the idea that you have no real idea of what you're supposed to do and you just guess. Discoverability is related, but that's if I want to learn, if I want to discover, how does it show me what's possible? Learnability is how easy it would be to learn. Guidance and feedback, you mentioned, help that learnability and help that discoverability, right? And give me some, we know from, well, since the first days of HCI that feedback is crucial to almost every action we take. And it's often missing with gestures, especially gestures that you complete and only see the result once you're done. And then I also added memorability. Can we, after we learn them, can we remember them a week later? We've done some studies on which gestures are most memorable. This is a set of difficult things to achieve, right? I mean, these are hard, and pointing with a mouse at our targets we can see on a screen, if you think through these criteria, most of these are made much more easy for pointing at buttons and things. Even if we think of a button on a screen, you know, the addition of an icon to the button is to help make it more guessable if the icon is well designed. And then tooltips, those little yellow, you know, tips that pop up if you hover to say what a tool button is. All of that is in service of these same properties. So how do we do this when we can't have a visual representation, or we don't? Do we hope that when we approach a gesture system, there is an on-screen maybe agent who's showing us how to do things? You know, are you here for the first time? Can I show you what you can do? You know, here's how you can act. But that's also a very visual thing. So for accessibility to say blind people, that probably isn't sufficient. I don't unfortunately come today with very many answers. Just an acknowledgement that these are really tough questions. It's not that I don't think we can't make some improvement here. But part of the challenge is being aware that users face these problems. So when we go into designing a gesture system, we think through this list and we try to maximize guessability, discoverability, learnability, guidance, feedback, memorability, and so forth. And even in the attempt, we'll probably do better than if we don't try anything.
Thank you, very good. So then we have a question from Marcel.
Yes, thank you. First of all, thanks for the talk. It was really interesting. And the first slides, you had these questions, and your first question had kind of the sub-question of what is a good gesture. Mm-hmm. And then you showed elicitation studies. And I always envisioned this data set in the end, where, for example, have one gesture that has a high agreement score, so a lot of people chose it. But then I have these other gestures in there which might have some other different properties that I, as a designer, find interesting. For example, the properties that you have shown there. Mm-hmm. Does something like this come even up? And how do I decide what actually do I choose then?
Yeah. So a lot of elicitation studies have been run in research. I get asked to review them all the time and usually say no, because I'm sick of them. I'm still interested in the methodological side. So if it's really changing and improving the method, which actually is what I take your question to be, then that's interesting. But just using the elicitation method for yet another thing is kind of familiar now. There are hundreds of these studies now. So, but you know, I think that's fine. You're asking methodologically, are there ways, I think, to combine designer insight and designer preference with just kind of following the elicitation method sort of without designer maybe influence. I know in practice they've used the elicitation method at Microsoft for some of the gestures on the current Surface line of products. And in fact, they used it as a starting point to get the gestures that they thought people would come up with first, but then they went in and changed things based on other principles like consistency with other products. Designers used some of the gestures in follow-up studies and found they maybe didn't perform as well as they had hoped, so they changed some aspects. I think the elicitation method shouldn't be followed just sort of like an algorithm with no discernment. And what it really does well is surface the variety of things people will come up with. But just taking that sort of as is maybe not as good as we can do, because we know things that the simple algorithm just doesn't incorporate. So it's kind of a combination, I think, where you find the sweet spot. So trust your instincts. You know, as I said in the talk, users aren't designers. We shouldn't make them designers, but we can get data from them that helps us.
Thank you. I would like to continue on the question of feedback. So let's say we're looking a little bit forward into different kind of user interfaces. What do you think for mid-air gestures we can expect from feedback in the sense of, you know, tangible bits, in the sense of ultra haptics, illusionary interfaces, new ways of touching things? So do you think that will radically change it, or is it just yet another feedback?
Yeah, well, I think in practice, what we'll see first is a priority placed on whatever the output display is that we're interacting with, if there is one, and there might not be, which is its own set of challenges. Maybe it's only audio or something. But assuming there's a screen, that will be the sort of first tier of feedback, because I think what we'll see is people can approach these things, these displays, in a walk up and use situation, and they need feedback on the display that they're viewing. We did some work, it was on that timeline of seeing how both children and adults interact with horizontal and vertical surfaces in science museums with gestures. And so they would walk up, and kids do very different things than adults, as we might guess, because kids aren't influenced too much. This was before they had iPhones as well, but they weren't influenced too much by what's in their pocket. And we had to show feedback on the displays so that they had some idea of how well they're gesturing. But I think it gets more interesting when there isn't a display. And so if we are in an audio only situation, or perhaps some lightweight haptics, the cases where you might not have a display are, I think, in more maybe mobile settings or wearable settings. Although even there, it is hard to get away from the fact that everyone has a phone in their pocket. I mean, most everyone these days. So there's often a display within reach, although maybe your hand's busy, or riding a bicycle, or not in a scenario where you can grab that phone. We're doing a project now that allows you to put little finger straps on your fingers and type on any surface. You can type on your lap, you can type on the wall, you can type on anything that can essentially create a sort of an impact of the finger. And we're providing feedback just through audio, and so that's an example where there isn't a display and we have to find some other way. But what we do know is that feedback really always must be present. And so whatever channel is involved in the interaction, I think, will be the best place to look to provide it.
Thank you. But didn't you just give an interesting methodological idea? If I go back to the children, so they maybe do different or maybe unexpected things. So would it be, I don't want to use really the word elicitation study, but would you then do an elicitation study to do no feedback to maybe elicit unexpected things? Could also be maybe then a little bit more methodological option.
Yeah, for sure. I think there have been child gesture interaction elicitation studies. I think there are at least a few, and they do surface different things. Kids are great because they're not constrained by what they think the technology can recognize.
Yeah, thank you. I think Jan has another question, maybe a little short round before we, or is it just your hand up?
No, I actually had one more thing that when you mentioned Octopocus, that took me back to a paper that we keep actually covering also in our classes, because I think it's a really ingenious design. François Gambretier did this. It's called Flow Menu. This is back from like 2000 roughly. One more showing our age, I suppose. But what I thought was really clever about it was a menu that you use to interact with a large wall display with your pen. And basically, as you put down the pen, it would pop up a menu, like a circular menu where you would select things and select submenus. And once you've done that for a while and you've gotten used to, in order to select this thing, you go out this menu, cycle, this section and go back in. After a while, you learned this movement and it became a gesture. And the system was designed so that after a while, the menu wouldn't even pop up anymore. So I love the transition from a command that you picked a menu into a gesture. And what I loved even more about it, if you came back to the system after 3 months and you'd forgotten all about it, you could just basically fall back to just let it show you the menu and do the slow, careful tracing. And I'm really wondering, is that since Susanne was talking about midair gestures a lot and asking about them, does that have any kind of possible translation to midair space? Has that been done, or is that something you've looked at?
I haven't myself. What you're referring to, I think, is Francois' adoption of marking menus that Kurtenbach did in his dissertation work in 93 and 94. So that's, I think he did it with the stylus on a display, and then Francois took it to wall-sized from a distance, I think, with a laser pointer. And so I'm glad you mentioned marking menus, because it does show that natural transition from learning by something that's revealed visually and then becomes a gesture through repetition. A more recent example that's not a marking menu, but a similar idea is actually right now on, I think, everyone's phone, probably in their pocket, which is swipe, the swipe text entry on the keyboard, which also was ShapeWriter, or before that academically was called Shark by Shuman Jai and Per-Ola Christensen. You tap your keyboard in a certain pattern to enter text, right, as you punch keys. But then if you stop tapping and just make the shape of the same of the word on top of the keyboard, you transition from tapping keys to stroking. So it's a similar kind of a learning through this motor action that you repeat, right? And so that's the really nice example. As far as finding out how we might do that in a midair scenario, it's hard for me right now to envision how we might do that without a visual component, like a wall display. Maybe there's a way that haptic feedback could kind of provide some feedback, but I think we'd probably need to see, these are very visual dependent until we become familiar with the motor movement, right? But I don't see why a recognizer couldn't reveal progressively how we're moving at a distance, something on the display. I mean, in many ways, it's similar to what Francois did, just take away the laser pointer and track the hand or something.
Thank you.
Yeah, it's interesting because even if I think about it, I'm using lots of shortcuts also in succession, one after another. And for me, actually, it's not anymore using keyboard in a conventional way, but rather in kind of, it's like a gesture rather, that happens to have touch points on the keyboard at certain points in time. Yeah. So it's so this question, when do people, what does it cognitively actually, what's the cognitive processes that makes this into a continuous motor movement that we would then argue is maybe the indicator for a gesture, where we have a continuous motor movement instead of single events or so. And this is, there's a very blurry boundary in between.
There is. And I think actually that's, at least in my conversations with Christensen and Shuman Jai, they would say that it's that blurry boundary that they're hoping to take advantage of, so that people just kind of tip over from tapping to swiping in this kind of natural way. I found myself, I had to force myself to try to do the swiping because it's easy just to stay stuck in the tapping of the keys. But I do like that the keyboard itself provides the visual legend to follow. Right, that's kind of an elegant idea there.
Yeah, I agree. Same is maybe interesting if you look at how gamers use, actually, the pro gamers, how they use the keyboard. This is completely different. Right. We use the keyboard, it's much more gesture-like. If you look at how they use it, actually, it's more like using an instrument, where we would also argue if you play the guitar or so. This is also, there are lots of gesturing involved in a way.
That's right. It's a chunking action too, right? We stop thinking of the individual motions, right? And we start chunking together. So I'm sure many people here play some kind of musical instrument. I play some piano and guitar, and you hopefully get to a point where you stop thinking about the individual keys and you start thinking about phrases of music that you express together. And that actually goes back to this notion of gesture as language, because if we get comfortable with gestures, we're putting the gesture together as a fluid action, and hopefully not worried about the individual, components or motion. When we're learning, we do it that way, but once we know it, it's more fluid, hopefully. Same with just typing, touch typing, compared to kind of hunt and peck for each key, like my father types still.
So Jacob, I think we are almost concluding. Let me come back to one of your examples that you had in your presentation. A movie that impressed me at one time, but also irritated, was The Minority Report. So on one side, it was exciting, it was all this new technology. At the same time, I think that actually, as you showed exactly that section, I remember a lot, when there was like a data analysis somehow. It was like today you would call like visualization, exploration. But then the data actually came, I think it was in some like acrylics, and then it had to be put to the side. I said, what? Come on, you do have all these wonderful things.
I know.
So relating to mid-air gestures, I was wondering, are we already understanding what mid-air gestures could do? Because I think we very much relate, okay, now in mid-air we can also type, or in mid-air we can also switch on our TV. But if you look at that movie, you would say, come on, this data comes here now, and that is actually not happening today. So how do we sort of discovered, these kind of novel gestures, what we could really do in midair? Because I have the feeling that in midair, it's even worse, that users are kind of very limited to their experience, let's say with smartphones, or limited to their experience with computers.
Yeah, that's a good question. I think that one of the things we need to call into question is HCI has a strong history and kind of a default value sometimes placed on, well, we say usability, but we kind of mean almost walk up and use ability. I remember when I was a student in my undergraduate days, Terry Winograd asked the question, what is more usable, a kazoo or a violin? Do people know what a kazoo is? It's sometimes not a familiar word. I'll type it in the chat. I think you spell it this way. A kazoo is this little, it looks like a canoe, kind of a little, or a kayak, but you know, and you can make a little bit of some music with it. It doesn't sound very good, but it doesn't sound very bad. Oh yeah, wow, look at that. Okay, perfect. You have an image. And the idea is that you can become an expert really within about 5 minutes.
Okay.
But that's the best you'll ever get, because it's very usable, but then that's it, right? Whereas with the violin, of course, you can spend a lifetime, and there's really almost no limit to performance. And so, for better or worse, this elicitation method is kind of got an assumption in it that we can and want to make things so that people can, like I typed, guessable gestures and easy to learn and perform and remember and stuff. But do we not allow the possibility that certain things, perhaps some mid-air gestures, might in fact need to be learned in a more explicit way, or even trained? If everything is just going to be as easy as a kazoo, it might also mean that the limits of what we can do are quite limited, just like with a kazoo. If we're willing to say, well, there's some learning here, it's maybe not quite so simple to just walk up and use it, but maybe we can do quite a bit more. So in the Minority Report, the gestures he's using are quite extensive, and I don't think would be guessable to most people. He's doing zoom, like, let's see if I can do it like this, right? I mean, this is hardly a zoom, like a pinch to zoom or anything. It's very different, right? it looks like it makes sense. It looks like it might work, but he's acting as a professional who is a police officer in the future, trained to do these gestures, whether they're good or not. So I just think sometimes we have to also step back and say, for the system and application we're considering, how much user training might make sense, and in what ways do they get trained? If they're doing midair gestures, do they have to be something they can just walk up and kind of guess and they're mostly right? Then we're dealing with a kazoo. In an airport, that's probably necessary, or a science museum. But in a professional, like an architecture firm or a automobile design firm, you know, maybe there's, the answer is more like a violin or something in between.
Yeah, then we're back to what you mentioned as a language. So you really maybe developing a full language with a syntax, which is actually also one of our goals we're looking at. Cool, great. That was awesome. I really enjoyed it. Thanks for giving us such wonderful insights. I think there was such a lot of information also that the video will probably be needed to recap of all of that. And maybe, who knows, if that project can also contribute to the dollar family, we will see. It's still going on, and we would be very happy to have you around again sometime.
Thank you for having me. I appreciate it.